One of the variables of geomorphology. How is matter transported once it's made available to be removed from a location? And as we've seen with fluvial geomorphology, it's a function of velocity and capacity. We know that wind has low capacity because it has low density. So that velocity is going to be a major player in how much stuff can be transported and what size can be transported. So size is the second condition that will determine the nature or how something is transported. So with Aeolian geomorphology, transportation occurs in one of three ways. Is it creep, which means it's moving along the surface of the earth? This is our largest particles. They are too big to be suspended or saltated, where they have can be impacted and then rebounded into the atmosphere. Saltation is that impact elastic rebound that causes suspension. And then the last is a suspension. These are our smallest total particles. They feel like big particles sometimes. We've all been hit by things that are flying in the atmosphere, but these are rather tiny particles for the most part, and they can be suspended for quite some distance. So starting with surface creep, the particle is moving, inching along piece by piece. So just like creeping along the bottom of a river, we're creating a high pressure zone and a low pressure zone. And if the wind is coming from this direction, it's going to act on this particle and create a high pressure cell here. Functionally, a low pressure cell automatically creates on the other side, and the particle is then pulled and pushed at the same time into that vacant spot. So the same physics that creates wind, where we move from high pressure to low pressure, now we're moving an agent, a particle, from the high pressure cell to the low pressure cell created. We've got some places on the planet where very large structures can be moved through a type of creep. One of the most famous is the Devil's Bowling Alley in the Southwest, and this takes place on something called a playa, which is a desert landscape that is relatively flat and has a lot of fine-grained materials. And when the wind is right, and oftentimes after the surface has become lubricated after some moisture, a little bit of wind will initiate movement of very large particles, sometimes the size of bowling balls, and push them several hundred feet or several hundred meters. So when the conditions are right, these things can move quite some distance. But for the most part, we're only creeping along the surface of the earth. These roughly make up about 20% of the particles moved. All right, if you're going to pay attention to the math here, the next element I'm going to talk about is saltation, which is about 80%. So that leaves the suspension to a very, very low, almost negligible amount. All right, so roughly 20% of all particles are moved this way. Once they are moving, synergy can keep them moving until the wind velocity is reduced. So what we need to do is overcome friction. And once that friction is overcome, then the particle can remain in action and continue moving forward. So the next mechanism is saltation. These particles are just a little bit smaller than the smallest size for creep. All right, so we're looking at about 0.2 millimeters in diameter. Again, this is about 80% of all of the total volume of material transported, so this should tell you how weak wind is for moving material. Most of that stuff is moving by creep or saltation. what's happening is we're creating an aerodynamic condition where a particle which has been in suspension drops out of suspension, hits another particle. Think of a cue ball hitting another ball on a billiard table. And that other ball then has the kinetic energy transferred to it, and it starts to move. So when you hit that particle correctly, it's going to then move in a parabolic curve up into the atmosphere, and it's going to take on this trajectory until it then falls, and if it strikes another particle, it will initiate saltation in that other particle. So there are a couple of things dependent here. One, that particle has to get struck by another particle in order for saltation to take place. And that particle has to successfully hit another particle for it to then transfer its energy into saltation of another feature. Now, if that particle hits very small particles, which is likely, it will then initiate then those small particles to move up at a higher trajectory where they are then in suspension and can be moved with the wind.